Hello and welcome to this tutorial on inheritance. We're going to take the concept of object-oriented programming and extend it a little bit now by discussing how we can use classes that derive from each other. We're going to start by defining a new class. I've got a blank Java program here with nothing yet. So let's add a new Java class, and the purpose of this tutorial is going to be to implement various electronic devices. Our base class is going to be the electronic device class. So go ahead and add that in as a new class. And common to all electronic devices is a concept of how old they are and how much power they consume and whether they're working or not, as well as a name. So let's go ahead and implement, like we would have before with object-oriented programming, a new class called electronic device that has a device name, which will be a string. We'll do a power rate, which will be a double, and that's how much power, let's say, per minute or per hour that the device consumes. We'll also create an age, which represents how many months or how many uses this device has. And let's go ahead and also add a lifespan property, which tells me how long the device should live for. So conceivably, when the age becomes the lifespan, then the device will stop working. So we'll have a Boolean alive, let's just call it alive, that will determine whether the device is functioning properly or not. Okay, so let's build a constructor for this by coming under source and insert code, and let's create a constructor that takes no parameters. And also let's create a constructor that takes in all of these parameters and sets them up. We're just going to leave off alive because we'll assume that the device is alive when it's created. So we'll say this.alive is equal to true, and that sets up our constructor here. We could implement defaults. So perhaps nothing will be the default name for the device. The power rate could default to 1 unit of time. The age will be 0. Lifespan, let's say, is perhaps 60 months. And alive will be equal to true for our device. Okay, so we have two constructors. Nothing really new here from what we've talked about before, except that we're going to extend this now and add a couple more features, and ultimately we're going to derive new devices from this electronic device. Let's add a getter for the name and also the isAlive. Okay, so we have isAlive and we have getDeviceName. That's going to allow us to access those two properties. Also down here, let's go ahead and override the toString function. And the default, or the behavior that I want to do, is to return the device name plus with power usage rate of power rate, and is age months old of a possible lifespan. Okay. I need to mark this as public so that we can actually get to it, right? Okay, very good. So now we have our toString method that's going to display all of this information, such as the name and the power rate and the age and the lifespan. Next, let's go ahead and add the override for our equals function. So let's insert the code for equals and hash code, and we're going to use the device name and the power rate and the lifespan, but let's leave off the age and the isAlive so that two devices that are the same name and the same power rate and the same maximum life will be equivalent to each other. and we'll use the device name and the power rate and also the lifespan on the hash code. So let's generate these two, automatically inserting the equals function and the hash code function for us. Very nice. And now I'd like to add a method to this electronic device class. Let's have a public void use function. This is going to allow me to make use of the device, and if the function is alive, I'd like to say something like the device name runs and consumes power. That's typically what electronic devices do. I'm going to then increase the age of the device by 1, and let's do a test for break, which will be a private function that we write next. That way, if the device is old enough, it's going to stop working. So we'll make this method private. And quite simply, it's going to say that if the age is greater than or equal to the lifespan, the expected lifespan of the device, then alive will become false. And let's do an output that says something like the device name breaks at age. Okay, so now we have a public method. We can tell the device we want to use it, and as long as it's still alive and usable, it's going to give us some output and then update its age, and then it's going to check to see whether or not it's too old and shouldn't be functioning anymore. And at this point, there's been nothing new that we've added that we haven't talked about before. We just have a simple class called electronic device that has some private attributes, constructor, some getters, and then the toString and the equals function that we've implemented. So let's go here into our main class and actually make use of this electronic device class. I'm going to create a new TV. Let's say we have a new Sony TV that consumes 20 units of power per unit of time. It's brand new and it should last us for 4 years. So if I do system out println on my TV, we should get the expected output here. So let's run this, and we see that we have a Sony TV with a power usage rate of 20, and it's 0 months old out of a possible 48. Great. Let's use our TV. So we have our use method, and let's use it a few times. And if we run this again, then you see that the Sony TV runs and consumes some power twice there. Okay. Now we wanted to test out whether this thing was going to break or not, so let's do a loop, let's say across 50 times. And this should give us enough uses of the TV that it should break after the exact 48 that we would like here. So we can test out our full functionality of this electronic device. So let's run this. And you see that we have, I'm going to scroll up here, and you see that the TV initially prints out, and then we get 48 different TV runs and consumes power because that's the use over and over and over again here. And then eventually, because the electronic device, when I tell it to use, it's going to run this test for break, and eventually it's going to break after it gets 48 months old. Okay, so everything looks good there. We have our electronic device, it's running quite nicely. And now let's extend this and get into the new concept for this tutorial. Inheritance gives us the ability to take an existing class and extend it and add new capability to it. So what I'd like to do at this point is take a new class and create it based on this electronic device class. So let's create a new Java class. I'm going to call this class a computer. And the computer is going to extend the electronic device. And what this means is, sorry, let me fix my spelling here. The computer extends electronic device, and what this means is that everything the electronic device can do, including all of its properties up here and its methods, now the computer can do. This allows us to reuse code and just define what's new and different about a computer. So certainly a computer is an electronic device, and it should have a name, and it should have whether it's alive or not, and how old it is, and how much power it consumes. But in addition, I want to have a concept of RAM. So let's make this int RAM here. And I'll also have a drive capacity, which will be 2 integers. These are going to be beyond my regular properties that we had in the electronic device, the name and the power rate and the age and the lifespan. In addition to that, the computer also has RAM and drive capacity. So let's define new constructors for this. So I'm going to come up here and insert a constructor. And I'm just going to insert the constructor with no parameters coming in, but notice we have a new option here where we can select the super constructor. And I'm going to select that and call super. This is a new keyword that tells us that in addition to when I create a computer, I want all of the work that's done in the super constructor, or the super class, or the class that the computer extends, to also be invoked. So we're going to initialize all of these properties up here in the super class. Notice if we rebuild a constructor now taking in these values, well, let's leave these off for now, and I want to call the super constructor with all these different properties, then the computer constructor takes in a device name and a power rate and an age and a lifespan, and it's going to invoke the super constructor within the electronic device to also initialize those. So whereas this super constructor is going to run this one without any parameters, this super constructor is going to run this one that takes these 4 in and set them up. Well, in addition, I can create a new constructor that takes in those 4 properties, the device name, the power rate, the age, and the lifespan, and I can also pass it a RAM and drive capacity. Notice what's happened here now is I'm taking in 6 parameters to my constructor. Let me bring these down so we can see them all. The top 4 here are what we have before that are getting passed to our super, and these bottom 2, RAM and drive capacity, are the new properties that I'm going to initialize my local instance variables here. Okay, so we have the ability to invoke the constructor in my superclass, or the class from which I inherit, as well as do work down here. Now the rule to follow is that the superconstructor must be the first thing that we call in a method. So do all of your customization, like initializing the RAM and the drive capacity, here at the end. So always invoke the superconstructor at the top. And if you're astute, you should realize that the RAM and the drive capacity here default to 0. So let's fix that and say that the average computer has 4 gigabytes of RAM and a drive capacity of 320 gigabytes. We'll do that in both the constructor here that takes no parameters and the constructor that takes 4. Now let's shift our focus to implementing the methods of this class. We've now got some attributes up here and the constructor set up. Let's implement the toString function, and I'm going to use the override keyword here, which means that I want to take the implementation that was done earlier and we're going to override it, meaning I'm redefining it and writing over essentially what was there. This method, toString, returns a string, and the work I'd like to do, typically we would say something like this device is running, or this device has been set up and it has this lifespan and so forth, like we did up here in the toString function of the electronic device, but we've already got that work done. So let's make use of that by calling super.toString, and that's going to reuse the code that I've already written. I'm going to invoke the toString method within my superclass, in this case the electronic device, and it's going to return to me this string that's constructed based on the properties earlier. In addition to that, I'd like to go down to the next line and indent in and indicate how much RAM I have, and also the drive capacity. Okay. Whoops, I need to remove that equals there. Okay, so now we've got that we're going to, if you invoke the toString function on a computer, it's going to go to its superclass, which would be the electronic device, and get this string, and then it's going to concatenate onto that, going to a new line, and then indicate the RAM and the drive. So let's go into our main, and now that we've done some work with the TV, let's create a computer. Let's call this del is equal to a new computer, and I'm going to call it a del precision, and it uses a little bit more energy. It's still brand new. It should last me 36 months, and then now I can pass it how much RAM and how much hard drive space I have. Okay, so we've got the new constructor that comes to us from the computer class that's expecting 6 parameters, adding in the RAM and the hard drive capacity. And let's just test out our toString by printing out the del. Okay, let's run this. And what we get here is our del precision with power usage rate of 35 and a 0 months old of a possible 36. This comes to us from the electronic device, and with RAM equal 40 and drive equal 500, that's coming to us because we added this on. So realize that the toString actually occupies 2 lines of code, or 2 lines of output, when we print out a computer now. Now let's create a new computer. I'll call it del2 is equal to a new computer, and this one I'm going to also be a precision, and it's going to also consume 35 units of energy, and it's brand new and lasts for 36 years. But this one is going to have more RAM and a larger hard drives. Okay, so I'll print this one to the screen as well. And then I'd like to do a comparison. Let's run. And we see that we get the different one here with the RAM of 8 and the hard drive of 750. And let's do an equivalence on these two. So let's do a comparison on between the two dels. So if this del is equal to del2, I'd like to say del and del2 are the same. Otherwise, paste this in and say that they are not the same. Okay, so do you think that del is equal to del2? Well, up until now, according to these 4 properties, they are, but then we deviate when it comes to the RAM and the hard drive. So let's run this. And oddly enough, we see that del and del2 are the same. And that's because if you look in the computer definition, we have the toString overridden in the constructors, but we haven't implemented the equals function inside of computer. We have an equals function within the electronic device, and all it's looking for is the device name and the power rate and the lifespan. So here in main, those things are the same with regard to del and del2. For example, if I made this this first one have a 4-year life cycle and ran this, now we're going to get that they're not the same. So up here, all they're doing is comparing these properties at the electronic device level, not the computer level. So let's go into computer and implement the equals. I'm going to insert the code for equals and hash code, and I do want to compare drive capacity and RAM in the equals, and let's go ahead and add those in the hash code function as well. Now by default, we're only looking at the RAM and the drive capacity, so if those matched, but if the properties up here in the electronic device did not match, we'd have a problem. So I'm going to modify what the NetBeans IDE built for me automatically by saying that I'm going to initialize my hash to super.hashcode. And here, right before, once I test to see that the object isn't null and that the classes match, I'm going to look to see if the super equals on these two are the same. Then I want to keep looking, so if they're not the same, then I'm going to leave and return false. So I'm going to insert this check to verify that the properties that are defined in the super are equivalent to each other. And if they're not, then I'm going to return false. Otherwise, I'm going to look at what's different and new. If we go here into main now, we can see earlier we said that they were the same if these first four matched. And incorrectly it said that they were the same even if these two RAM and drive capacity were different. But now that we've implemented the equals function at the computer level, let's run this and see what we get here. And we see that del and del2 are not the same, even though at the super level they look equivalent. The RAM and the hard drive is now being looked at. So just to prove that this is still working, if I do make all of these properties match and run this, then we get that they are the same. Okay, quite nice. So let's put this back and not steal this guy's RAM. Okay. Now that we've defined our equal and hash and our constructors for this subclass computer, let's add some new methods to it. We can, in addition to overriding things, we can extend one class to another, in this case in the computer, by adding capability. So let's look at a new method. I'm going to define this as upgrade, and I'm going to take in a new amount of RAM that I'm adding to my computer, and just say that RAM is equal to itself plus new RAM. And this will allow me to add new capability to this computer class. In addition to extending and adding properties, I can add and extend by defining new methods. So it's not just overriding existing methods that came in earlier classes that we're inheriting from. So here's an example of a method where we're adding new capability. Inside of main, I could say something like del.upgrade and add 12 gigabytes of RAM to it. And then print out my del. And if we run, we should see that our del precision actually now has 16 gigabytes of RAM because I added 12 to it. Okay. In addition to adding new methods, I can override existing methods. So if you go back to the electronic device class, we had a method called use that checked to see if it was alive, and if it was, it aged it. If we use our del right now, that'll work just fine, and it will increase the age of this del and consume some power on it. So let's see that. We see that the del precision runs and consumes power, right? Which is, I want to print out the del and del2 are the same. I want to print out the del itself. And so we see that it's now 1 month old since we used it once here. Okay, let's override the use command though. You'll notice that the electronic device, if I use a computer, use isn't redefined down here in computer, so the program is going to find the matching method here at the next level up in the class hierarchy. But if we override the use command, and match exactly the definition that we had before, make sure that the interface is the same. There was public void use, and in the electronic device it's public void use. So make sure that you've got the same parameter and return type, otherwise the override won't work properly. The first thing I'd like to do is invoke super.use so that the computer is going to age, and if it's too old now, it will set the alive property to false. But additionally, sometimes computers fail because they've maybe overheated or some such thing. So randomly, what I'd like to do is determine maybe 10% of the time when you use a computer, it's going to fail. That's not really good reliability for reality, but for our purposes, I want to generate a failure so that we can see it. So I'm going to come up here and add a new property, actually. It's going to be private static random r is equal to a new random. And I'm actually going to mark this as random or as static because I only want one random number generator shared for all objects of the computer class. There's no reason for me to generate a new random object for every single object of computer. So if I right-click on random and fix the imports, we'll bring in Java util random, and R is now going to be usable to me later on in my method. You'll also notice that we've got this equals new random not in the constructor, but here, because it is static, I can just do it once at the class level. Let's go back down to our use and say if r.nextInt on, let's say 10 is equal to 0, meaning at 1 out of 10 times, this is going to occur. I'm going to set alive to be false, and I'm going to system out println the device name breaks while running, saying that maybe it overheated. Okay. Let's say while running too hot. Now you notice that we're getting some errors here because alive and device name aren't recognized. But this is strange because we are an electronic device. A computer is an electronic device, and an electronic device has the device name and the alive properties, so how come this isn't working? Let's check these out. The error that we're getting is that the alive has private access, and device name also has private access. So if you go up here and notice, device name is private, and alive is private as well. Now this gets into an issue of visibility and scope. If something is marked public, then anyone within and without side of the class can get access to it. If it's marked private, then only within the class can we access these properties. So we've got a problem here. We'd like to mark these as private so that no one can mess with them, but the subclass needs to have access to them. Now there's a couple of ways of getting around this. We can have accessors and modifiers, like we've got the get device name here, but sometimes we don't want to expose the ability for the main program to edit these. We just want to be able to allow subclasses to edit them. In the case of the alive, we definitely want alive to be writable and to be able to mark it as false. So we can mark it as protected, which means that only within this class and any subclass later can you edit this. And you'll notice that the alive, once it's marked protected, the alive method, or the alive access there, no longer has an error. Now with the device name, I don't want anyone to really change this device name. Once it's set, I want to leave it alone. But we do have this get device name function, so why don't we make use of that down here in our computer. And we'll use this accessor to pull the device name. Okay, so it's really important to understand the difference between private, public, and protected. Now one could argue that all of the properties in a class should be marked as protected so that the subclasses can gain access to them. The trouble with that is that it breaks this notion of encapsulation. So I don't necessarily want my computer class to go in and change the device name and to change the age and so forth. So I should use getters and setters. Or in the case, sometimes I do want you to be able to modify, so I'll just mark those as protected. Okay, now at this point we've got the ability to use the computer, and sometimes it's going to break maybe 10% of the time. So let's go up here in our main program and tell the Dell to use itself, and we'll see if we get a breakage. In this case, it runs and consumes power. Let's run it again. It runs and consumes power. I don't necessarily want to just sit here and keep pressing run until we get a power failure. So let's do while del.isAlive. And I'm going to tell the del to use. And what we'll get is, if we run this, we're going to get, there we go, okay. So it runs and consumes some power one time, and then the next time we run it, it breaks. Let's see if we can get one with more. Okay, here's one where it ran, it looks like 3 or 4 times before it breaks. All right, here's one where it actually ran quite a bit of times as I scroll down. Okay, very good. So it looks like our computer is running just fine here. I don't know if you saw it, but as I was implementing this do while loop, I had del.isAlive. I chose to use this accessor, or this getter, but I do have access to the alive property directly. So I could modify this to say do while del.alive. And if we run that, compiles and runs just fine. Okay. Notice here that the del precision runs and consumes power, and eventually it breaks while it's running too hot. And this really isn't what I want. If you look at the computer and go up here, the electronic device, I've marked this as protected, and I said that anything that's marked protected is visible within the class or any subclass that inherits from it. That's partially true. I mean, that is true, but it's only the partial story. It's also visible to anything within the same package. You'll notice that the computer is part of this package, CSE 1302_0401, and the electronic device is also within this package, but so is main. So the trouble is, main should not have permissions to get to this alive property. I don't want to be able to do this. So in order to fix that, I'm going to come over here into my project, and I'm going to right-click and create a new Java package. So let's say we want to call it the CSE 1302 classes. Okay. This is going to create a new package for me, and what I want to do is move my electronic device by clicking and dragging it and refactoring it, and bring my computer into this as well. Okay. Now, if you expand this, you'll see that the computer is part of the, scroll up here, is part of the CSE 1302 classes, and the electronic device is part of the CSE 1302 classes. In the order that I did these, it generated this automatic import for me, but I can remove that since now they're part of the same package. So the electronic device and the computer are now part of the CSE 1302 classes package, and the main is still part of the CSE 1302_0401 package. Now we're getting the error that I want us to get. Notice that alive should not be accessible to us because it's protected. It's only visible within electronic device and within any class that inherits from electronic device and anything within that same package. And now that main is in a separate package from these classes, I'm going to be forced to use my isAlive getter. And that's really good because I don't want to be able to say something like del.alive is equal to false. I shouldn't be able to modify that property. So be careful when you are defining protected attributes, you keep them within a separate package, and then only the class and the subclasses that come from it will be able to get to those. Just to show that everything is still working fine, I can compile and run this, and we get exactly the proper output that we want. Our TV still works, our Dell Precision computers are still working, and we can make use of the Dell. Okay, the last thing I'd like to do in this tutorial is create a new class based on the electronic device. So I'm going to right-click on my CSE 1302 classes package and define a new Java class. I'm going to call this mobile phone. And I'm going to paste this code in here that I've already written before starting this tutorial just to save us some time here. And let's go through and examine this. The purpose of me adding this mobile phone is I want to show that we can inherit multiple classes from the same class. So you'll notice that the computer certainly extends electronic device, And the mobile phone also extends electronic device. So the mobile phone is going to have the name, the power rate, the age, the lifespan, and alive, and we'll be able to make use of the equals and the use and the test for break methods. Here I'm going to add a new property called battery life to my mobile phone. So the phone has a certain amount of energy that it contains and stores. I've defined 3 constructors taking different amounts of parameters. The first takes none and invokes super. This is just like our computer did. Right. And I need to set my battery life. Let's say by default it should be, let's say 5 hours of battery life. If I give it 4 parameters, then I'm going to invoke the super constructor and initialize, and also set my battery life by default to 5. And if you give me 5 parameters, the original 4 plus the battery life, I'm going to invoke my super constructor, but set my battery life to what you pass in. Let's scroll down to the toString first, and you'll notice that I'm doing a similar trick to what I did in the computer class toString, where I'm going to invoke super.toString and then just add on what's new. So within the context of the mobile phone, I'm calling super.toString, and then I'm displaying how much battery the phone has. I've also overridden my equals, just like I did earlier in my computer class. I'm doing the same thing here with the hash code to make sure that my equals and my hash code all work just nice. You notice I'm also using my super.equals to make sure that we're not getting a false true if the device name is the same. So I want to make sure I make use of that equals function as defined in the electronic device. Okay, what I've changed in this is I've overridden the use command, or the use method, to check for the battery life. So if I have some battery left, then I want to use the mobile phone and deduct from the battery life, so that not only is the device aging, as we defined in super.use, but every time I use my phone, its battery is dying. And if the battery goes dead and has a value of 0, then I'm going to, when you tell me to use the phone, I'm going to say the phone doesn't have enough power to use. So now let's make use of this mobile phone class. Let's go into main, and down here at the bottom, I'm going to make use of some code, again, I've already written just to save us some time. And I've got a problem here. Look, it's complaining about this quite heavily because it doesn't know what a mobile phone is. Now earlier we had defined computer and electronic device, and then I moved them into this package. But we've got a problem. I've got a package CSE 1302.04.01 that main is in, and mobile phone is defined within this CSE 1302 classes. If we come up here to the top of main, you see that we're importing the computer and the electronic device from the CSE 1302 classes package. So very similar to using random or a decimal formatter. If I just right click on this and say fix the imports, then it's going to add the CSE 1302 classes.mobilephone import, and everything is looking much better here. Almost much better. Notice that my curly bracket needs to get moved down so that I'm still within the main function. And once I do that, then everything is much better for us here. I have an object called droid of type mobile phone, and I'm passing it the name, the power consumption, the age, and how long it should live, and then the battery information. So I'll just print it out, I'll use it, I'll print it out again, and I'll use it a few more times. Let's comment these out so you can see just using it once and the change that that's going to make. So let's run. When we come down here, you see that the Droid X with power usage rate of 10 is 0 months old, of 24 with a battery life of 3. And then if I use the droid, then it's going to say that it runs and consumes power. That's from the electronic device, right? So it's aging and testing if it's broken or not. And we get that because in the use method, we are calling super.use. So that code is going to be run. Okay, and then we're going to print it out again, and notice that it's gotten older and its battery life is a little bit less. So let's use it a few times and see what happens when we try to use it when it doesn't have any battery left. Here we go, it's running twice more, and then on this third use there should be no energy left in it, so it reports that it doesn't have any power. And if you look at the code for that, you'll notice that we're not going to invoke superuse because the battery life was equal to 0. So we're just going to say that it doesn't have any power. Now let's just review what we've talked about here with respect to inheritance. We defined an electronic device to begin with. That was nothing new about this. It was like every other class we had defined earlier. Then we inherited from it using the extends keyword and created a computer, overriding and using this notion of super. And then we had to come in here and change and mark the Boolean to be protected so that we could get access to it. We inherited a new class by extending electronic device and making the mobile phone, and throughout we've made use of these objects of these different classes. And that'll do it for this tutorial.